Scene script. Have you ever pondered what existed before the beautiful galaxies we admire today? Just over 13 billion years ago, our universe was born in a colossal explosion of energy and matter that we now call the Big Bang. This was not an explosion in space, but rather an explosion of space itself, an expansion of everything that exists. At that moment, all the matter and energy the universe would ever contain was concentrated in an incredibly hot, dense point. In the immediate aftermath of the Big Bang, the universe was a seething cauldron of primordial soup, an almost perfectly uniform blend of matter and energy. Picture a vast cosmic sea, so hot and dense that not even atoms could form. Everything was in a state of flux, a sort of cosmic chaos that was almost unimaginably hot and incredibly dense. As the universe expanded, it cooled. Slowly, the primordial soup began to change. Particles of matter clung together, forming atoms. These atoms then began to gather, pulled closer and closer by the inexorable force of gravity. Yet despite these clumps of matter forming, the universe remained remarkably homogeneous and isotropic, meaning it looked the same in every direction and at every point. But here's the thing that boggles the mind. The universe we see today is anything but uniform. It's a cosmic tapestry of galaxies, stars, planets, and vast stretches of empty space. So how did we get from a uniform soup of matter and energy to the structured universe we see today? That, my friends, is the question at the heart of our story. It's a question that has puzzled scientists for decades, and it's the one we're going to dive into today. So from this sea of uniformity, how did the first galaxies form? The answer to this question leads us into the next chapter of our cosmic tale. Stay tuned as we unravel the mysteries of the universe and delve into the birth of the first galaxies. In the universe's early years, a cosmic symphony began playing. Quantum fluctuations, these tiny variations in the density of the universe, were the first notes of this grandiose orchestration. They were so minute, so delicate, yet they held the promise of something monumental. Picture a calm sea, seemingly still and tranquil. Now imagine a single droplet breaking the surface, creating ripples that spread out, multiplying and interacting with each other. These ripples are akin to the quantum fluctuations in the early universe, causing tiny differences in density from one region to another. Now, as the universe expanded, these fluctuations, these ripples, grew larger and larger, encompassing vast cosmic distances. These subtle differences in density were the birthplaces of gravitational attraction, pulling matter into denser regions, much like an unseen celestial magnet. It was a dance of forces, with gravity leading the waltz. The denser regions of the universe, where gravity was strongest, began to attract more and more matter. Like spectators drawn to a captivating performance, particles of matter couldn't resist the pull. As time went on, these regions of attraction became denser and denser, pulling in more matter and growing in size. From these gatherings of matter, gas, and dust, the first structures in the universe began to take shape. They were not yet the grand spiraling galaxies we know today. No, they were the raw, unpolished gems waiting to be sculpted by the hands of time and gravity. These clusters of matter were the seeds for our first galaxies. This cosmic symphony, this dance of forces, it's still playing even now, billions of years later. And as we continue to listen, to observe, we uncover more about the origins of our universe, the formation of galaxies, and our place in this cosmic symphony. So what happened next? How did these clusters of matter evolve into the galaxies we see today? Stay tuned as we delve deeper into the birth and evolution of galaxies in our cosmic symphony. Now let's delve into the fascinating formation of the first galaxies. It's a tale that takes us back in time, to an era when the universe was just a newborn, only a few 100 million years old. After the Big Bang, the universe was a hot, dense soup of particles. It gradually cooled, and matter began to clump together under the influence of gravity. These clumps of matter, primarily composed of dark matter and gas, were the seeds of the first galaxies. Now picture this. These early galaxies were quite different from the ones we see scattered across the cosmos today. They were much smaller, often just a fraction of the size of our own Milky Way. And they weren't the grand spiral or elliptical shapes we're familiar with. Instead, they were irregular, chaotic, and patchy, reflecting the turbulent times of their birth. And what about their composition, you ask? Well, these fledgling galaxies were primarily filled with hydrogen and helium, the two simplest and most abundant elements in the universe. They contained only trace amounts of heavier elements, which astronomers lovingly refer to as metals. These metal-poor galaxies were the sites of intense star formation. The earliest stars, made from this pristine gas, were massive and short-lived. They exploded as supernovae, releasing energy and heavier elements back into the galaxy. This process of star birth and death, repeated over billions of years, gradually enriched the galaxies with heavier elements, setting the stage for the formation of planets and life as we know it. But back to those first galaxies. Over time they collided and merged, growing in size and complexity to form the diverse array of galaxies we see today. The formation of these first galaxies set the stage for the universe as we know it. They're the cosmic pioneers, the first structures to break the darkness and light up the universe. And their story, it's our story too, for we are all made of stardust, born in the heart of those very first galaxies. But how did these first galaxies evolve into the ones we see today? A question that has sparked countless studies and fascinating discoveries. Galaxies, much like living organisms, go through a process of evolution. Over billions of years, they grow, merge, and sometimes even collide, creating the diverse cosmic landscapes we observe in the night sky. Let's start with merging. Galaxies are not solitary entities. They exist in clusters, vast cosmic neighborhoods, if you will. Over time, the gravitational pull between galaxies can draw them together in a celestial dance. This cosmic tango can result in a merger, where two galaxies become one. This process is essential for galaxy growth and has played a significant role in shaping the galaxies we know today. But galaxies don't just grow by merging, they also grow from within. The heart of a galaxy is a bustling hub of star formation. Dense clouds of gas and dust, known as nebulae, collapse under their own gravity to form stars. These stars light up the galaxy and contribute to its mass. This ongoing process of star formation ensures that galaxies are ever-evolving entities. Of course, not all stars live forever. They have lifespans, and when they reach the end of their lives, they explode in spectacular supernovae. These explosions scatter elements across the galaxy, seeding the raw materials for new stars, and the cycle continues. It's a cosmic cycle of birth, death, and rebirth, a never-ending symphony of creation and destruction. The galaxies we see today are snapshots of different stages in this evolutionary process, each with its own unique history. So the galaxies we admire today are the result of billions of years of cosmic evolution. They are testimony to the dynamic and ever-changing nature of the universe, a testament to the power of gravity and the enduring life cycle of stars. They are, in essence, living museums of the cosmos, each one holding the secrets of our universe's past, present, and potentially even its future. With the dawn of new technologies, our understanding of galaxies continues to grow. Groundbreaking telescopes like Hubble and the James Webb Space Telescope are leading the charge in this cosmic exploration. Since its launch in 1990, Hubble has been instrumental in our understanding of the universe, unveiling supermassive black holes, measuring the universe's expansion rate, and capturing light from the ultraviolet to the visible spectrum. Its ability to access ultraviolet wavelengths makes it an invaluable tool in our cosmic toolbox. Then we have the James Webb Space Telescope, a shiny new addition to our observational arsenal. Primarily observing the universe in infrared, Webb's sensitivity is 100 times greater than Hubble's, allowing us to peer at objects whose light was emitted over 13.5 billion years ago. It's like having a front-row seat to the birth of the universe. One of Webb's recent discoveries includes the confirmation of an exoplanet, LHS 475b, almost the same size as Earth. This discovery, made possible by observing dips in starlight as the planet passed in front of its host star, hints at the vast potential of Webb in uncovering the mysteries of our universe. It's a fascinating era for galaxy studies indeed. With these powerful tools, we're not just observing the now, but also piecing together the story of the past, unveiling the secrets of the early universe. As we continue to venture deeper into the cosmos, our understanding of galaxies will only expand. Who knows what future discoveries await us in this grand cosmic journey? From the birth of the universe to the formation of galaxies, our cosmic journey has been nothing short of awe-inspiring. We've delved into the birth of wonder, the cosmic symphony, the birth of the first galaxies and their evolution. We've peered into the future of galaxy studies, standing on the shoulders of scientific giants like the James Webb and Hubble Space Telescopes. Isn't it breathtaking, this vast cosmic ballet of stars and galaxies dancing to the rhythms of the universe? If you enjoyed this journey through the cosmos, please like, comment, and share this video. Let's continue to explore the universe together.